Hello everyone. Can you trust an AI agent to query your production database? That's actually the wrong question. The better question is, can you trust the architecture that allows the agent to use that database? Most AI demonstration jumps straight into the SQL generation. The model writes a query runs, the answer comes back. It looks impressive, but enterprise AI doesn't work in that way. Before an AI agent is allowed anywhere near a production system, the architecture has already made a series of decisions. Can this tool be used? Who is allowed to use it? What data can be accessed? How is the request validated? How is every action audited? Those decisions matter far more than whether the model can write SQL. Last episode, we built enterprise memory. Memory allowed the agent to remember work it had already completed. A question that took 218 milliseconds the first time came back in just 1 millisecond the second time. No retrieval, no vector search, no database, just memory. But memory only helps when the agent already knows the answer. When a brand new business question arrives, the agent has to interact with enterprise. It needs fresh data, real data, and that's where Today's layer begins. Today we are going inside enterprise tools. One thing before we start, this episode is not about SQL. Today, SQL simply happens to be the tool the planner selected. Tomorrow, it could be Salesforce, SAP, ServiceNow, GitHub, Jira, Kubernetes, AWS, anything for that matter. But the architecture is exactly the same. Enterprise tools are the hands of an AI agent. The planner decides what should happen. Enterprise tools make it happen safely. And there are three ideas I want to show you. First, the agent chooses this tool. Second, the tool is governed. Third, the result becomes evidence, not the final answer. Let's see what actually happens. Okay, so what you see here is Nexus IQ platform, like which we use for the demo. If you saw my previous episodes, you would have known. So let's go back to agent, layer two, agent planner. The planner receives the business request. Just here, if you see analyst use customer churn result and suggested next action for the sales team. This is the previous one which we used. Notice, like I'll just give start planning. So you have to notice what does not happen. There isn't a hard-coded rule that says if the question contains the word churn, execute SQL, right? That would be automation, not intelligence. Instead, the planner reasons about the request. It identifies the business objective, like it's understand the goal, and breaks it into multiple tasks. Determine what information is required, and only then chooses the right tool for each task. If you see here, structured revenue data is required for historical sales. So it is for use SQL. The product trends, the production adoption documentation is use a knowledge base, that is knowledge layer. The high risk customer accounts like customer relationship history use Salesforce or any other database where it has been showed. There are three different problems, three different subtasks, three different tools, like each tool for each subtask, right? Each one selected deliberately by the planner. So that is what makes this as an enterprise agent instead of a traditional application. Now let's follow the SQL tool because knowledge layer we have already seen in layer 3. So I'll just go back to the enterprise tools. I'll just dispatch the question like it is. I have pre-added the question. So yeah, now let's follow the SQL tool. And really, you need to watch what happens before any SQL reaches the database. Let it run. And just one more thing, I just want to tell you, for the demo purpose, I'm just doing it manually. So the idea is when we complete all 9 layers individually, we'll deep dive each layers. So once we complete all 9 layers, probably we'll create one end-to-end product covers end-to-end build, enterprise level of AI agents, which will cover all the layers, and we will do it through API. So every call will happen API without any manual intervention, which we will show. Okay, so now coming back here, let's follow SQL tool. Let's just watch what happens before any SQL reaches the database. The first thing you will notice is something very important. The LLM never connects directly to the database, right? So everything passes through enterprise tool layer. The planner invokes the tool registry. The tool registry invokes the MCP. MCP server. The MCP server discover the live database schema, and not from the documentation, not from the prompt, from the database itself. So if you see here, like I'm using MySQL, if you would have seen Nexus IQ platform, you'll be able to connect different databases. We can do federation layers and everything, but we have a different demo for that. For this particular demo, I'm using MySQL. So the schema which you are seeing here is part of MySQL database, which I created for this demo, and we have tables inside each of it, right? So the MCP server discovers the database schema, and it identifies available tables as well. Then retrieves the column definitions, right? Again, it is live. There are no assumptions. Like you can see, the metadata is being retrieved from each schema, and we are still not ready to execute it before anything reaches production. So what we need to do is, like, we need to, every query needs to be validated, right? So before that, the SQL has all the parameters it requires, and if you see here, it generates a SQL query. That SQL query is generated. I'm using Claude here. This is more of a text to SQL. So it's recreated. It generates a SQL query, and before that, we are not still ready to execute it because it needs to be validated, and the query is validated. And if you see here, it passed validation. This validation needs to run every time we run a query. There are no exceptions. Only after validation is completed, the execution begins, and then another architectural control appears, which is nothing but a row level security. This is very, very important if you see. So what you are seeing here is analyst level. There are two things I have mentioned here. It's more of a role based access control. I have analyst who has the row level security enforced. The admin who doesn't have any access to the row level, because he'll be able to see all the rules. So what I choose here is the analyst is running this. So there is a row level security is enforced, and filters injected with customers only. So if you see the response, what you're seeing here, for example, just to show the different things, like, the key insight is like, okay, how can I say? So here you can see the row is Southern Africa only. It's being selected here because that is the row level access we have. So if I run the same query for admin, let's see what is happening. So why the role-based access control is very, very important. Again, I'm just going back to the Nexus IQ platform demo. So if this platform is properly having access control list, which is authorized by the Microsoft authentication, and we have a role-based access control. Role-based access control is nothing but who needs to see what, who have permission to see what, right? In an enterprise, for example, if the Nexus IQ chatbot is there in the enterprise, anybody can check, right? It's not something, finance data should not be reached to everyone. So that's where the role-based access control comes into picture. I hope you are aware of it. Again, so coming back here, if you see, this time I ran as an admin without row enforced. If you see here, it brings, there are 5 regions. You can see the difference between the analyst as well as the admin, right? The result itself is different now, right? Yeah. So because access control isn't implemented inside the prompt, it is implemented in the UI. So it isn't implemented inside the Claude. Like the database is enforcing it. The AI agent cannot bypass those rules. So this is not the future, but this is part of the architecture, right? Now comes the result becomes evidence. Now comes the part that many AI demonstrations skip. The SQL query completes real rows, real business metrics. Suppose the result shows North America has a moderate revenue, but unusually high SIN, then declining customer engagement, right? So that information does not go directly to the user. Instead, it goes back to the planner, because planner is still reasoning. Now it combines 3 different sources: the structured SQL result, what we have seen here, and the customer relationship information coming from CRM, and the product knowledge retrieved from the knowledge layer. Only after all 3 sources have been collected, validated, ranked, and merged does the plan construct the final context. Only then is everything passed to the language model. The SQL query was not the answer. It was the evidence. The agent is still thinking. The reasoning loop is still running. Enterprise AI is not built around individual tool calls. It is built around orchestrating evidence from multiple enterprise systems before making a decision. So let's bring everything together. The enterprise tools are the hands of an AI agent. The planner decided which tools to use, not because it was hard coded, but because it reasoned about the problem. So the every tool invocation was wrapped with the governance, schema discovery, validation, security, audit, database enforced permissions, and when the tool returned the data, the agent still wasn't finished. The data become evidence, one piece of much larger reasoning process. That's the difference between consumer AI and enterprise AI. Consumer AI often treats tool execution as the end of the workflow. Enterprise AI treats tool execution as one step inside a governed reasoning loop. The intelligent isn't it writing SQL. The intelligent is knowing when to use SQL, whether it should be used and how it should be governed. The model is not what makes this system trustworthy, but the architecture is. Next episode, we will move into layer 6 model router. Back in layer 2, the planner selected a model before any reasoning began. But how was the decision made? Should the request go to GPT-5, Claude, Gemini, a local model, or a private enterprise model? In layer 6, we will see that choosing the model is not a configuration. It is another architectural decision driven by cost, capability, latency, compliance, and data sensitivity. I'll see you in the next episode. Thanks for watching.